Okay, so today we looked at how the outliers affect the median and the mean. And so by adding a number that's really, really small or really, really large, it pushes the mean back and forth, the median not so much. And so we're going to look at how that affects here. And so there are two statistics, a 13 and a 16 without calculating. Well, I can see that the middle number is going to be 16. So right away, 16 goes there, and without calculating, the other number has to be the mean. And so, how do I see that? When I look at this, if this is the mean, it's because the median's here, and there are some big numbers, 18, 19, 20, but compared to the 1 and 2, like you're really expecting the mean to come down because of those numbers. Um, the first thing I would have done was put them in order. And so, because I want to know what the median is. And so I've got 0, a 90, 95, and then 100, 100, 100, 100, 100, and 100. Let's check 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So the median is 100. And so why might it make sense? Because otherwise that zero, um, the zero is so small compared to the rest of the scores that it is bringing down their average, their mean. And I totally misspelled words, sorry. I'm so close to the board I can't actually look what I'm typing. Here again, I put them in order, but I can tell right away. So bowling at 300 is a perfect game. Didn't miss this. That's like 13 strikes in a row to make that. 250 is awesome. 275 is awesome. 243 again. 290. They missed one pin and one frame. Like that's pretty awesome. Um, Let's see. Yeah, that 120 is so low that it's messing everything up. So again, the 120 um, is an outlier, and later on we'll figure out the actual calculation for figuring out outlier has to do with the MAD. Um, is an outlier and is bringing down the average. Yeah, it's just such a low score compared to those others that it's really messing them up. Okay, Quiku surveyed 10 teachers. Which is the true? Like when I look at this, there are 10 teachers, so I know between the fifth and sixth dot is the average. So I'm looking at 30 and a half is the median. 30.5 is the median. Oops, median. But then when I look at, you've got some 65-year-old, 60-year-old, 56, like you got some older teachers there, and then you've got like 24, 25-year-olds. And so in this case, the average is going to be higher because you've got all these veterans. I want to call them old timers. You got veterans there. The median is greater than the mean. No, the mean and the mean are no, they're not the same. But yeah. Um, and so I get that the median is less than the mean. Um, the more senior teachers um, are bringing up the average, the mean. Okay, dot plot with 5 plots that has a median 14. Right away, I'm going to put one at 14 because then I'm going to try to make the median that. But the mean is going to be less than 14. So if I put one at 15, I put one at 7. Now I know that the mean is less than 14, and I can put one at 16, one at 8, something like that. And so the median is 14 for sure because it's the middle dot, and then the numbers that are down low end up messing up that whole thing and bringing down the average. Click one dot. So this one took me a while. I actually got the answer wrong the first time I did it because I didn't calculate the mean ahead of time. And so I added all these up, like 2 plus 8 is 10, 3, 3, and 4 is 10. So that's 20. 5 and 5 is 10. That's 20, 36. And so the average is 4.5. And so to make the median greater than 4.5, I need to put another dot at 5. That gives me that the median is 5. I mean, technically, I could put the median anywhere, but by adding more numbers, I'm adding to that the total. So if I chose a number like 9, it actually pushes the average up too much, and so, I mean, yeah. So you need a number right at 5 to make that true. Then add 1 point to this dot plot to make the median equal the mean. So now I want to push it to 4.5, and so I put 1 at 9. And so if I were to calculate these, I had it at 36. I now have it at 45. The average is 5 when I divide by the 9 dots that are there, and the median is 5. And so that's the only solution that works for that. Here, there are 3 steps to get to 54, which makes each step 18. That would be then 36. This one is 72. And then well, I'm going to do the easy ones first. You've got 3 ounces, 85 grams, no problem, because when it becomes 30, it's 850. Then it gets a little trickier. You've got 3 ounces going to 85 grams, and then you're getting to 12. So I end up multiplying by 4, and then 85 times, wait, where did I mess up? Oh, I'm not in grams. Okay, there we go. I'm going to use this one. I'm going to use the kilograms to ounces for this one because this is in ounces. This is in kilograms. So it's 4 kilograms so yeah, I'm not using that one. Totally messed it up. Let me erase. Okay. So let's try this one more time. So I've got that 4 kilograms is 141 ounces, about. And so to get to 12, I'm going to multiply by 3, and then 145 times 3, I've got 312, carry the 1 is 423. Then I've got pounds to kilograms, and they gave me this one here, that 11 pounds, libras, is 5 kilograms. And then I'm trying to get to 6 pounds. And there's not a nice way to go from 11 to 6. And so, I mean, it's not nice. It's multiplied by 6/11ths. And so I had to do 5 times 6/11ths. And I get that that's 30 divided by 11. So ugly. And that ends up being 2.7. Yeah, that's all they're looking for, I'm pretty sure. And so I got them all right. If you have trouble with that dot plot, 6, 7, I totally understand. And if you have trouble with number 11, totally understand. Those ones are a little bit more difficult. But if you have any questions, please ask in class. If not, I'll see you in the next video.